Hi, welcome to Mathematics from KSSM. So today we are going to discuss chapter 5, Trigonometric Ratios, and I will divide this chapter to two videos, but because I think it's quite long for you all to stay in one video. Okay, so you can refer to your textbook for this topic. Okay, let's get started. Okay, let's discuss what is trigonometry. So trigonometry is a branch of mathematics that deals with distances of height of object, which can be found using some mathematical techniques. The word trigonometry is derived from Greek words tri meaning three, gon meaning side, and metron meaning measure. Okay, what can you do with trigonometry? Trigonometry is very important. Okay, as what we have discussed maybe earlier, you have discussed about this one. It was developed for astronomy and geography, but scientists have been using it for centuries for other purposes too. Besides other fields for mathematics, trigonometry used in physics, engineering, and chemistry. Within mathematics, trigonometry is used primarily in calculus, which is perhaps its greatest application, linear algebra, and statistics. Since these fields are used throughout the natural and social sciences, trigonometry is a very useful subject to know. So it's very important. Some when you study in physics in Form 4, then again you will use the concept of trigonometry to solve the problems. Okay. Okay, now, very important for you all to understand what is trigonometric ratios. So for this topic, we are going to discuss about more on right angle triangle. What is right angle triangle? A right triangle is a special triangle that has one of its angle a right angle. What is right angle? Right angle is 90 degrees angle. So you can tell it is a right triangle when one angle measures 90 degrees, or the right angle is marked by a little square on the angle whose measure is 90 degrees. You look at this one, the triangle here. So we have one of the triangle, we mark with a little square like this. So, and then the value of the angle is 90 degrees. Once there is an angle which is 90 degrees, so we call it right angle triangle. So this one is example of right angle triangle. So another one you can look at, this is a right angle triangle. So because one of the angle is 90 degrees. But this one is not right angle triangle because we cannot find any 90 degrees angle here. So this is not a right angle triangle. Okay, now for the first part, we want to identify the opposite side, adjacent side, and hypotenuse based on the acute angle in a right angle triangle. So you want to know which one is opposite side, adjacent side, and hypotenuse. Okay, so what is the meaning of acute angle? Okay, apa maksud angle ini? Okay. So you have discussed earlier in the mathematics, maybe in Form 1, Form 2. Acute angle is angle between 0 and 90 degrees, meaning larger than 0, smaller than 90. Okay, meaning smaller than 90 degrees, we call it acute angle. So from this triangle, you can see here, X and Y are examples of acute angle because the value is less than 90. Okay, so now we want to determine which one is opposite side, which one is adjacent side, and hypotenuse based on the acute angle. So the first diagram, the acute angle we use is angle PRQ. Okay, and we label as X. Okay, so for this acute angle X, hypotenuse always the longest side and opposite to 90 degrees. That one is very easy to identify. You know this one is 90 degrees, so the side which is opposite to 90 degrees, we call it hypotenuse. Okay? And then for the angle X, the one that opposite to angle X, we call it opposite side. And the other one, of course, adjacent side. So from here, we can get hypotenuse is PR for X. And opposite is PQ. And adjacent is QR. Okay, now let's look at another one. We use angle QPR, we mark as Y. Okay, so the hypotenuse still the same, the one with the longest side and opposite to 90 degrees. And then the opposite side is opposite to angle Y, and the other one will be adjacent side. So from here, acute angle QPR, so Y, hypotenuse equals to PR, opposite is QR, adjacent is PQ. So very important for you all to know which one is opposite, which one is adjacent. For hypotenuse, I think it's quite easy to identify the longest side and opposite to 90 degrees. So that one will be hypotenuse. Adjacent and opposite depends on what angle you refer. Jadi kena faham ya yang mana satu side, nama-nama side sebab nanti nak guna formula. Jika tidak, kamu tak boleh guna formula. Okay, look at one example here. Say, let's I mark, identify the opposite side, I mark as O, adjacent A, hypotenuse as H. Based on the given angle in the table below for all the following right angle triangles. Okay, so you identify which one is hypotenuse, which one is opposite, which one is adjacent. So I want to look at this one, part C, yang bahagian C sahaja. B, A and B you can try yourself. Okay, look at C. Okay, part C, we have two right angle triangle here. We have PQT and QST. There are two right angle triangle here. So for triangle PQT, so here is the triangle PQT. So the angle we use is TPQ. Let's use the angle TPQ. So use TPQ, the hypotenuse is PT. The opposite is QT, and the adjacent is PQ. Okay, if you refer to RQS, this angle, the bigger one, so the angle is QRS, so QRS is here. Okay, and this is 90 degrees. Okay, so you can just draw one square, here small square. So SR will become hypotenuse, the one that opposite to QRS. QRS is SQ, so this one will become opposite side, and QR will become adjacent. So you must know which one is hypotenuse, which one is opposite, which one is adjacent. Okay, now next, we want to make and verify the conjecture about the relationship between acute angles and the ratios or side of right angle, sine, cosine, and tangent. Sine we just write as sine, S-I-N, cosine, COS, cos, tangent, TN, tangent. Okay, so it's abbreviation, singkatan dia, sine, cos, tangent. So formula, kita ada formula ni. For sine is opposite side divided by hypotenuse. For cosine is adjacent side divided by hypotenuse. For tangent is opposite side divided by adjacent. So from here we can have the formula that we call it Sohcahtoa. Sohcahtoa, I think you have heard before, I think. So get to know Sohcahtoa. What is this? Okay, so S represents sine, O represent opposite, H hypotenuse, C we use for cos, represent cos, A is adjacent. Okay, tangent we use T. Okay, so now what is Sohcahtoa? So you look at this triangle, ABC. So we are using this Sohcahtoa, meaning if you apply formula for sine, so meaning opposite divide hypotenuse. For cos, car, C-A-S, car, so it's adjacent divide hypotenuse. Okay, for tangent is toa, toa means opposite divide adjacent. So it sounds a bit strange, but we can use this for us to memorize the formula. Okay, look at sine x. Let's look at ABC, a triangle. So we use angle x. So for angle x, we want to find sine x. Let's put the value. AB is 3, BC is 4, AC is 5. Okay, so sine x equals to opposite divide hypotenuse. For x, opposite is AB, hypotenuse is AC. Then AB divided by AC, so 3 divided by 5. So we get the value of sine x, 3 divided by 5. For cos x, cos is adjacent divided by hypotenuse. So adjacent is BC. Okay, adjacent is BC. So here adjacent is BC. So divide by AC. AC. So we get 4 divided by 5. So we have cos x equals to 4 over 5. For tangent x, toa, toa. Okay, so opposite divide by adjacent. So opposite is AB, adjacent is BC. Then we get tangent x equals to 3/4. Meaning from here we can get the value for the sine, cos and tangent. So this one we call it ratio, trigonometric ratio for sine, cos and tangent. So you refer to triangle ABC also, but we use angle Y now, angle Y. So for angle Y, BC will become opposite, AB will become adjacent, and AC still hypotenuse. Okay, so what we get from here, sine Y equals to sine Y, sine saw opposite divide by hypotenuse, so 4 divide by 5. Cos Y adjacent divide hypotenuse, so 3 divide by 5. Tangent toa opposite adjacent, so 4 divide by 3. So this is how we get the trigonometric ratios for sine, cos and tangent. If you think that this one can help you to memorize easier, so you can use this method. Okay, example, sine, cos and tangent ratios. So we want to find sine of the given triangle using Sohcahtoa. So look at this triangle. Given the angle here is 53.1 degrees. So sine for angle B, this angle, equivalent to opposite divide hypotenuse. So opposite 16, hypotenuse 20. So 16 divided by 20, you simplify, you get 4/5 or 0.80. So this is the value of sine theta. So sine any value 53.1 degrees. Okay, for cos, adjacent divide hypotenuse. So from here, adjacent is 12. Hypotenuse is 20. So 12 divided by 20, 3/5, equivalent to 0.60. Okay, for tangent toa, opposite divide by adjacent. So 16 divided by 12, so you get 5/3. So 1.67. Normally, when you write the value of trigonometric ratios, you write in the simplest form. So this is the fraction that you get. If you can make it write in the simplest form, so you write in the simplest form. Like 16 divided by 20 become 4/5. Or you can just use calculator to calculate, so you get the final answer in decimal number. Okay. Okay, now let's look at this situation. What happened if we use the same angle, but we increase the size of the triangle? Okay, the fixed acute angle, angle-nya tidak berubah, hanya lukis lebih besar. Contohnya side ini, ini 4, sekarang you increase jadi 8. When you increase 8, meaning the other side also will increase. So you can look at here is the size original one is 3, 4, 5. Here becomes 6, 8, 10. Here become another one. So I miss out one. Okay, 9. Okay. Okay, now we look at one by one. Sine 36.87. So look at the first diagram, the small one, 36.87. So from the first diagram, we get 3/5. Okay, opposite hypotenuse. So 3/5, 0.6. Okay. If we use for the second one, it becomes 6 divided by 10, but also 0.6. For the third diagram, 9. So here is 9, the missing part. 9 divided by 15, so 0.6. Okay, so what we can say from here, okay, even the triangle is different in size, but for the same angle, it will give same value. Okay, so cos 36.87, we also can try cos 36.87. For the first triangle, we get 4 divided by 5, 0.8. The second one, adjacent, adjacent divided by hypotenuse, 8 divided by 10 is also 0.8. For the third triangle, adjacent 12 divided by hypotenuse 15, we also get 0.8. Okay, so you want to try for tangent also can, tangent, toa, opposite, adjacent. So 3/4 for the first triangle. Second triangle, 6/8. Okay, third triangle, 9/12. So you look at the value, all give same value. meaning trigonometric ratios only depends on size of angle, not length of side. If you remains the angle, tidak ubah angle dia masih sama, maka nilai sin, cos dan tangent tidak akan berubah. Okay, itu maksudnya. Okay, now we look at the next learning standard. So what happened to the value of sine, cos and tangent if we change the size of angle? Right? Look at, we have two triangles here, PQR. So we increase from 10 degrees become 20 degrees. So let's put the second one is P1, Q1, R1 just to differentiate untuk tunjuk perbezaan dia. Okay, untuk sine 10 degrees, sine 10 degrees from the first triangle, PQ we let the length become same for both of the triangles. Ini sama, triangle dia sama panjang PQ. PQ equals to P1 Q1. So when you increase the angle, side RQ dengan PR akan berubah. Mesti berubah sebab you sudah increasekan angle dia. So it must increase. Okay. So now what happened to the first one, 10 degrees, RQ is 1.8, PR is 10.2. But for 20 degrees, Q1 R1 become 3.6 and P1 R1 become 10.6. Okay, so now we look at the value. Sine 10 degrees equivalent to 1.8 per 10.2, so equivalent to 0.1765. This one you use your calculator to calculate. Use sine, sine 10, so you get the value. Okay, sine 20, 3.6 divided by 10.6. So you can use the formula Sohcahtoa just now. So I hope you already know how to use that formula. Sine 20, 3.6 divided by 10.6, so 0.3396. So what I want you all to see here is that when we increase the angle for sine, the value of the sine also increase. Okay, so meaning when angle increase, value of sine also increase. Okay, now we look at cos. Cos 10 degrees equivalent to adjacent divide hypotenuse. So 10 divided by 10.2, so equivalent to 0.9804. Okay, now let's look at the second triangle, cos 20, 10 divided by 10.6, so it becomes 0.9434. So what happened? So for cos, as angle increases, the value of cos decrease. So you can see it becomes smaller. Okay, so it's not same as sine for cos. For cos, as angle increase, the value of cos decrease. Okay, so this one all we discuss for acute angle. Tangent 10, now we'll look at the tangent 10. Tangent 10 degrees equivalent to 0.1800. Tangent 20, 0.36, meaning increase. So for tangent, when angle increase, so value of tangent also increase. Okay, so this is, you must know this one, because later on when you solve problem, so you know whether your answer is wrong or right. Okay, now from there we can say the larger the size of acute angle, the larger the value of sine as its value approaches 1. So meaning the value of sine 0 equals to 0. So when the angle reaching 90 degrees, the value of sine become 1. So meaning from 0 to 90 degrees, the value of sine increases when angle theta increases. Okay, for cos, the smaller the value of cosine and its value approaches 0. Okay, you see cos 0 equals to 1. Cos 90, 0, meaning when theta increases, the value of cos decreases and becomes 0 when the angle becomes 90 degrees. Okay, so for tangent 0 is 0, it increases, but at 90 degrees it becomes undetermined. The value, it is infinity. Okay, this is how it change, depends on the value of angle. Okay, let's look at examples. So mostly when we have discussed all about trigonometric ratios, of course there will be question for you all to solve. Okay, the diagram on the right shows two right angle triangle. Determine whether all trigonometric ratios of angle x and y are equal. State the reason for your answer. Okay. Okay, solution, we can try for sin x and sin y, whether we get the same value or not. Okay, so sin x here, opposite divided by hypotenuse, 3 divided by 5. Sin y, opposite divided by hypotenuse, 1.5 divided by 2.5. So we also get the same value, 3 over 5. Okay, for cos x, we do the same thing. We get cos x 4 divided by 5, adjacent divided hypotenuse. Cos y 2 divided by 2.5, also same value. Or you want to write in decimal also can. This means 0.6, here also 0.6. Here 0.8, here also 0.8. Tangent x 3 over 4, tangent y also 3 over 4. So what is the conclusion for this one? The trigonometric ratios of angle x and y are equal because length of corresponding side of the two triangles are proportional. So what is proportional here? Meaning this length, side and this side 3 cm reduced to half, 1.5. All the side reduced to half. 4 cm reduced to 2, 5 cm reduced to 2.5, meaning it is proportional. When it is proportional, then the value of trigonometric ratios also equal. Kalau you nak double pun boleh. Contohnya ini times 2 times 2 times 2. So from 6, 8, 10. So you also get the same answer. Okay, next. Okay, determine the value of sine, cosine, tangent of acute angles. So from here, we start to solve problem involving trigonometric ratios, sine, cos, and tangent. So look at the diagram. Diagram on the right shows right angle triangle PQR. Calculate length of PR, sine PRQ, cos PRQ, and tangent QPR. Okay, look at length of PR. This is the hypotenuse. Okay, you still remember Pythagoras theorem based on the diagram, right angle triangle. If you want to find the hypotenuse, meaning you want to find C squared equals to A squared plus B squared. So meaning C equivalent to square root of A squared plus B squared. So we're going to apply Pythagoras theorem for this one. You want to find PR. PR means the longest side, the longest side, hypotenuse, equivalent to 15 squared plus 8 squared. Square root of 15 squared plus 8 squared. So equivalent to square root of 289. Use calculator, 17 cm. Meaning we get the hypotenuse is 17 cm. So you want to use formula for sine, cos, tangent. You find the dimension first. Panjang dulu. Cari panjang dulu baru kita boleh gunakan formula. Okay. Contohnya sine PRQ. PRQ. Angle sini. PRQ. This angle sine opposite divide by hypotenuse. Maksudnya ialah QP divide PR. QP divide PR. So dapat 15 divide by 17. So ini value untuk sine. Kalau cos PRQ, cos angle di sini, adjacent divide by hypotenuse. Okay. So 8 divide by 17. Tangent QPR. Sekarang nak cari yang ni pula. Tangent di sini. Tangent di sini ialah toa. Opposite, adjacent. So 8 divided by 15. So meaning what we do, once you get the question, you look at the side. If the side, the value or the length not yet given, you find the length first. Then only you apply the formula for sine, cos, and tangent. Okay. Do remember how to use the Pythagoras theorem. Okay, another formula. Another question. The diagram on the right shows right angle triangle PQT RQS. PQR is straight line. Straight line. Given the length SQ 6. SQ ialah 6. Calculate value of length QR. Okay. Length PT. Okay. Sine QRS. Cos TPQ. Tangent PTQ. Tangent QSR. Okay. So what we do, we need to find the length for all parts first, because we are going to apply sine, cos, tangent. Mesti ada, semua length mesti ada dulu. Tandakan dulu length dia. Okay, diberikan ialah apa tadi? SQ 6 cm, SQ 6 cm. So you can see this symbol, tandaan ini, meaning T is the midpoint. So this is same length. So 6 divided by 2, 3. So here is 3, here is 3. Okay, so based on the Pythagoras theorem for triangle PQT, if here is 3, 4, then PT is 5. Okay, that one you can calculate using Pythagoras theorem. Okay, and then SQ given 6, SR 10, so you can calculate for QR using Pythagoras theorem. If you can remember the value for the triangle using Pythagoras, so here is 6. Okay, here is 6, meaning here is 8, and here is 10. 6, 8, 10. Okay, so let's try to calculate using Pythagoras theorem. Length of QR, QR. Okay, so QR equals to hypotenuse is 10. So meaning 10 square minus 6 square. The longest value one minus the other one. So 10 square minus 6 squares, we get square root of 68, then we get 8. So QR is 8. PT, PT is hypotenuse for this triangle. So PT equals to 4 squared plus 3 squared. Okay, so PT equivalent to square root of 25, so get 5 cm. So here is 5 cm. Okay, sine QRS, then you use the formula of sine, cos, and tangent. Sine QRS, QRS, so sine, opposite divided by hypotenuse, 6 divided by 10. So you get 3 over 5. Cos TPQ, TPQ, so angle here, cos, adjacent divide hypotenuse, so 4 divided by 5. Okay, so you can write here, actually I cannot write here, so you write here. Okay, so tangent PTQ, 4 over 3. Tangent QSR, QSR, tangent this one. So adjacent 6, TOR. So QR is 8, so 8 divided by 6, 4 over 3. So ratio value should be given in the simplest form. So you can simplify the values, you get the simplest form for the answer. Okay. Okay, the third question. Let's say we have PQR, the triangle. So PQ is marked as Y, PR is X, RQ is 1. Okay, so it is known that sine theta, so look at this angle theta, sine opposite divided by hypotenuse, so X divided by 1, meaning X equivalent to sine theta. For cos theta, adjacent divided by hypotenuse, so Y divided by 1, so we get Y equals to cos theta. So from here tangent is TOR, opposite, adjacent, so we get X over Y. So what is X just now? Sine theta. What is Y just now? Cos theta. Then we get the formula that relate sine, cos, and tangent. So we can say tangent theta equivalent to sine theta divided by cos theta. Okay, now, is this valid for all angle? Let's say theta is QRP. Okay, QRP. Now we discuss another angle. I put here is beta. Just to show to you, for this one, you can try yourself for this one. I put this one as beta. So if theta is beta, QRP is beta, is the ratio of tangent beta still sine beta divided by cos beta? Adakah dia sama formula dapat? Okay, kita boleh tunjukkan. Sine beta is Y divided by 1. Sine beta equals to Y. Cos beta, X divided by 1. Meaning cos beta is X. So from here, tangent beta, opposite divided by hypotenuse, Y divided by X. So what is Y just now? Sine beta. What is X just now? Cos beta. So meaning tangent beta equivalent to sine beta divided by cos beta. Meaning this formula can be applied for all angle. It's valid for all angle. Apa-apa angle, formula tangent ni boleh digunakan. Okay, number 4, if sine theta 0.6, cos theta 0.8, calculate tangent theta. So you use the formula just now. Okay, sine theta 0.6 divided by 0.8, so 3 over 4, so we get 0.75. So you must know the formula that relate between tangent, sine, and cos. Okay, another one, same thing. So you can try also this one, sine theta given, tangent theta given, calculate for cos. So it's just one type of problem solving. So you can simplify. So you get cos theta ialah square root of 55 divided by 8. Okay, for in this topic, for the square root 2 here, we also call cert. Okay, later we discuss using the word cert. Cert 55 divided by 8. So you can write also in decimal form. If they want you to write in decimal form, you can write using the calculator, you calculate, so you get. If they don't want you to use calculator, so you leave your final answer in this form. Okay. Okay, number 6, problem solving also. Given that PR 20 cm, sin QPR 3/5. Okay, sin QPR, this angle. Okay, so you can just sketch a bit at your question. You can mark. So QPR, sine meaning opposite divided by hypotenuse. Okay, so meaning here 20 cm, 5 times 4. So here also times 4, meaning QR is 12 lah. Okay, so sine QPR 3/5. So use the formula sine. Sine QR divided by PR 3/5. QR divided by 20, PR 20. So we find QR 12 cm. Okay, so how to get PQ? PQ is, this one is hypotenuse. So 20 squared minus 12 squared. QR dapat 12 tadi kan? Okay, so you kira square root of 256, then PQ is 16 cm. So you dapat semua length. Soalan panggil cari apa? Cos QPR. QPR cos adjacent divided by hypotenuse, meaning PQ divided by PR. PQ is 16, so 16 divided by 20, so you get 4/5. So meaning you must know what step to start. If they give you information about length, so make sure you completed the triangle to find the length first. Then only you can use the formula for sine, cos, and tangent. Okay, so this is another formula that we have, problem solving that we can use to solve. Diagram on the right shows right angle triangle PQT and RQS. Given PQR and STQ are straight line, calculate the value of cos x. So from here, determine the value of RQ first. RQ. Okay, so this is RQ. So here 12, 13 meaning QT. QT is 5. So we calculate. You calculate, so you get TQ. TQ using Pythagoras theorem, you get 5 cm. And then SQ, SQ is 2 times TQ, so here is 10. So RQ is 26 square minus 10 square, square root. So you get 24. So here is 24, RQ. Okay, so there's cos x equivalent to cos x, adjacent divided by hypotenuse, meaning 24 divided 26, 12 divided by 13. So given that the hypotenuse of right angle triangle is 8, or square root 8, determine tangent theta if tangent theta is 1/2. So I think you try to do it yourself. So the answer for this one, determine tangent, so answer finally we get 1. Okay, so I think you better try yourself for this one first, then you can refer to the answer. Okay, number 8, the same question using the same concept, but here given cos 60 equals to 0.5. Calculate length of the PS. State answer correct to that 2 decimal places. So from here, length of PQ equals to length of QS, given here. So meaning if angle here 30, angle QSP also is 30, because here is same length. Okay, thus PQS equivalent to, ini angle sini, total angle 180, 30 meaning here is 120. Okay, so SQR is berapa sini? So 120 here, so meaning here is 60. Okay, so given cos 60, 0.5. Okay, so we dapat 0.5. 0.5 is equals to 1/2. Okay, so you use the formula QR divided by 10, adjacent divided by hypotenuse. Okay, so QR divided by 10 equivalent to 1/2. So you solve, you get QR 5 cm. Okay, here is 5 cm. So the question need you to find length of PS, PS here. Okay, so PR from here 10, here is QR we get 5, meaning here is 15, 15. So for the SR we get is 10 squared minus 5 squared. Look at this triangle, QRS. So here is 5, here is 10. So meaning we get SR equivalent to square root of 75. Okay. So thus PS equivalent to, look at the largest triangle one, PRS, the whole triangle. So meaning PR here is 15, SR is square root of 75. So you use Pythagoras theorem, PS equivalent to square root of 75 squared plus 15 squared. So you get PS 17.32 centimeter. Okay, so you can refer to some of the combination for Pythagoras triples. So refer to this one. This is the hypotenuse C, A, and then B. Okay, if you refer to the value, you can get this triples like 3, 4, 5, 5, 12, 13, 6, 8, 10, 8, 15, 17, 7, 24, 25, 9, 40, 41. If you can memorize, better. If you don't know, if you cannot memorize, then use Pythagoras theorem. Okay, so that's all for this part. So I hope you can go back and read through all the examples in the textbook and then do exercise in the textbook. Okay, do subscribe for more videos on this topic. That's all. Thank you.